All right, so what we're going to do is do a quick recap on the unit circle. So this is going to take us back to the task we did with the triangles, where I wanted you guys to work out the coordinates on a unit circle on a plane. So let's start with a 30-degree triangle. So you can see here that I've got 30 degrees. I'm just going to slot that in there. Now, what we can see here is that I've actually already pre-filled my information. So I've worked out my adjacent and I've worked out my opposite. If you're wondering how I got those values, remember we looked at the trigonometric ratios for right angle triangles, in that, for example, cos of 30 equals adjacent over hypotenuse. So in this case, I was trying to find that value there. Putting that into my calculator, keeping it in degrees, I got the answer √3 on 2. Using sine, I was able to find my opposite length as well. So what we can see here is that now this triangle is a little bit bigger than the unit circle, but the point that this triangle makes with the unit circle is right there. So following along the horizontal axes, which we know is cos, and our vertical axis is sine. So cos here is going to be my x-axis. So that's going to represent the x coordinate here. So that'll be √3 on 2. Now, the y value of the coordinate here is going to be the movement up the vertical axis, and that's going to be 1/2. Now I'm going to take the same triangle and flip it over. So apologies for the text on the back. So again, that triangle is going to be right here. Now, using our symmetry properties and what we know about a Cartesian plane, the second quadrant is where x is negative, but our y coordinate is still positive. So that will mean that this value here is going to be negative √3 on 2, and this value here will be 1/2. Now, sticking with that, I'm going to flip this upside down, and we are now in our third quadrant. So in our third quadrant here, x is negative, as 2 is y. So that means that will be negative √3 on 2, and this will be a negative 1/2. Now, last but not least, we're going to work into our fourth quadrant here, and got that the wrong way, so just there. So again, that's 30 degrees, which means that my x coordinate is going to be positive, and my y value is going to be negative. So when you're doing this unit circle, just gone out of frame a little bit, you need to make sure that you are considering the properties of a Cartesian plane. Now, one of the things here that I forgot to mention at the very start is that our unit circle actually starts from here and works in an anti-clockwise direction, which means my starting value will be 0 degrees or 0 in radians, and it will end at 360 degrees, which is 1 full rotation, or 2 pi in radians. So I might actually quickly fill that out now before we move on with the other triangles. So up here, that's going to be 90 degrees, or in radians, it'll be pi on 2. This here is going to be 180 degrees, or it'll be pi. And down here, that'll be 270 degrees, or that will be 3 pi on 2. All right. So now let's keep working our way with our next lot of triangles. So now I'm going to do the next one here, which is a 45-degree triangle. So that's going to be my angle there. So with a hypotenuse of 1 and an angle, or a reference angle, sorry, of 45 degrees, my opposite and adjacent length is actually √2 on 2. So here I'm going to write this as √2 on 2, and then √2 on 2. So again, flipping this triangle to the left-hand side. So we're going to have the coordinates here, negative √2 on 2, because remember the x value is negative for the coordinate on this in the second quadrant, sorry. And then my y value here is going to be √2 on 2. Flipping this triangle down here, the symmetry property, so right here, we know that x and y are both negative, so that means that this will be negative √2 on 2, as 2 will this. And then lucky last, we've got our triangle in here. Sorry, wrong way. So our triangle down here, and this coordinate right there is going to be positive root 2 on 2, and then negative root 2 on 2. So hopefully now you can see what's going on. So I'm just going to quickly label this as my first quadrant. That's my second. This down here is my third, and that's my fourth. So you can start to see the properties of what's going on here. So now what I'm going to do is use my next triangle, which is the 60-degree triangle. So that's my purple one here. So moving all the way up here, so we can see that this time my adjacent length is a half, but my opposite length is root 3 on 2. So filling this information in here, so we've got a half and root 3 on 2. Now using this triangle again, and I'm going to flip it. Just forgotten how I'm going to flip it. Yep, just there. So that's going to be negative a half and positive root 3 on 2. And then moving down to the third quadrant here. So this point down here is going to be negative half and negative root 3 on 2. And then flipping to the fourth quadrant here. So this coordinate down here is going to be positive half and negative root 3 on 2. Now to complete this unit circle, we've got a few more things we have to do, in that you can see here that I've got some blank coordinates going around. Now think about the term the unit circle. What we imply with that is that the radius is actually 1 unit. So in this case, my coordinate here is going to be 1, 0. Up here it's going to be 0, 1. To my left it's going to be negative 1, 0. And then down here is going to be 0, negative 1. And that's it for the unit circle.